Hello friends, welcome back to BitSize Machine Learning. Today we're going to continue on our end-to-end ML in 15 steps. In our last video, we talked about how to do feature engineering. In this video, we're going to talk about how to handle missing values, specifically imputations. So let's get to it. First of all, let's take a look at the structure of where we're at in the project. So let's run the tree function and using our folder. So let's just run this. And currently, our Jupyter notebook is underneath the notebooks folder, and which is called the 9th Jupyter notebook, which is called handling missing data. And then our data is underneath the data folder, which is the housing.csv. Okay, so now we're going to import all of our packages that we need. So the Pandas, passlib, numpy, etc. We are also going to import SimpleImputer from sklearn.impute. This one is the new one. So for imputing the data. So we're going to import all of that. And we're also going to load the function called create income bins to create the binned version of our dataset. So we're going to load housing.csv into a variable called df, and we're going to use this create income bins function and our dataset to create a binned version of our data. So let's just run that. So now that our data is loaded into the df binned and then also binned using the create income bins, we're using this version of the dataset and then also the stratified shuffle splits function to create the train and test dataset. So let's just do that. Now that our data is split into train dataset and test dataset, now we're going to copy only the train dataset for our imputation process or handling missing data process. We're not going to use the test dataset. Test dataset is reserved for the very end when you're testing how your model is performing. So never use test data. So we're only using the training dataset. So let's copy the train strat.copy using the copy function and then copy that into a new data frame called dftrain. And also let's use a info method to take a look at the structure of this dataset. So let's just run this. And as you can see, we have 10 variables, and then the first 9 are all float. These are all numerical. Our last one, ocean proximity, is object, which is not numerical, which is important. So the next one is not null values. So if you look at it, only the total bedrooms, this column has 16,351 entries, and then all the others have 16,512. So the missing values only exist in this total bedrooms column, which is 16,351. So there are a few methods to correct this. So I'm going to talk about 3 different methods to handle the missing values in this total bedrooms column. So the first one is called drop the entire feature. So we're going to drop this total bedrooms column from this entire dataset. So in order to do that, let's create a data frame called df_drop, and we're going to use the dftrain that we copied earlier, and we're going to just do drop function. So drop function has a few parameters. The first one is called axis. Axis is basically 0 is the rows axis and then 1 is the columns axis. So we're dropping columns, so we're going to select 1. And then also the next one is called columns. So which column that we're going to drop. So the column that we're going to drop is called total bedrooms. So after this, we're going to use the df_drop, this new data frame that we just created, and then we're going to take a look at the structure using the info again. So let's just run this. As you can see, we previously had 10 variables. Currently, we only have 9 variables. So the total bedrooms column is not there anymore. So, and then as you can see, the not null value columns are all the same now, and then total bedroom column is gone. So this is the first way of doing to handle the missing data. It's called dropping the entire column or the feature. In our case, it's total bedrooms. So what if that you don't want to drop the entire features because it's important? In that case, you can do the second approach. It's called dropping the NA values per row. In order to do that, let's create another variable called df NA drop. So we're going to use the DataFrame, the original one. And then we are going to use, instead of the drop function, we're going to use the drop NA function. In this one, drop NA is going to grab only the rows where the data frame has NA values, and it's going to drop those rows instead, not the column. So let's do df NA drop, and let's take a look at the structure. So let's just run this. After running it, as you can see that we still have all of the 10 variables. And then we also have the object at the end, this last ocean proximity. But if you look at the not null values, which is 16,351, they're all 351 now. Previously, it was 6,512. So as you can see, after we drop the rows, everything is normalized to total bedrooms this. So when you do the drop NA values of rows, it's only going to drop all the rows where the total bedrooms column has NA values. So it's going to drop all of the other samples as well. So in this section, we're dropping only the rows, not the column. So just a quick summary. In this first one, we're dropping the entire feature. In this second one, using the drop NA, we're only dropping where there is NA in the rows. So we're getting rid of a lot of samples here. Okay, so that's the second method of handling the missing data. So those are the two extremes. How about that we don't want to either drop the columns, we don't want to drop the columns like this, and we don't want to drop all the samples like this either. So there's a third method, which is kind of sits in between. So we're going to fill, instead of dropping anything, we're going to fill those NA with values, which is also called imputation. So there are two ways that I'm going to present today how to do imputation. The first one is imputing with fill NA. So in order to do that, let's create a df filled, this new variable. df filled, let's going to create or copy the DataFrame dataset first using the copy function. And then after that, let's figure out what's the median value of that total bedrooms column is, and then put that into a new variable called median. And then df filled this new variable, which has the total bedrooms column, and then let's call the median function. After this, it's going to this line is going to grab the total bedrooms column of the df filled, this data frame, and it's going to calculate the median of that column only, and then put that into the median variable. And then after that, we're going to grab this column of this variable, and then it's going to equal to, we're going to overwrite that column, and then we're going to use the fill NA function. And fill NA function, we're just going to give the median that we just created in this line, and we're going to fill the median of that column. The NAs are all replaced with that value. And after that, df filled, and going to take a look at the structure. Okay, let's just run this one. And as you can see, we have all of our 10 variables here. And if you look at the not null values, we are at the 16,512. And then if you look at the total bedrooms, we didn't get rid of it. So 512. So that is the maximum amount of the rows that we have. So we didn't get rid of it. We only filled up the NA values in this one with the median that we've calculated in this row. So that's one way to do it. This is a more manual way to do it, using the median value to impute the NA values in our total bedrooms column. However, in our we previously imported the SimpleImputer using the sklearn's impute, and we're going to use the SimpleImputer to do the exact same thing. First of all, let's select only the numerical variables from our data. That's called numerical df and df num. And then from our df train, let's select d types, and let's include only the np.number, which is basically, this line basically means that from the training dataset, let's select only the numpy numbers columns. Basically, it's going to only select the float64 columns, and it's going to exclude this object, which is ocean proximity categorical variable. So our df_num variable only contains the numerical columns. And after that, let's create the imputation object. Let's call it imputer. Imputer is equal to, so we've imported the SimpleImputer function before, and within the SimpleImputer function, let's do this strategy. Strategy is going to be equal to median. So basically what we're telling it to do is, using the SimpleImputer, we will use the median as our strategy. So the imputer object is now created. After that, we're going to use the imputer.fit method to learn about the median of our numerical columns. So when you do fit method is going to, it's not going to do anything. It's just going to learn about the median of all the numerical columns in this data set. And then after that, let's create the actual data frame using imputer's transform function. So again, we're going to use the numerical df. So it's going to use whatever is learned using the fit, and it's going to transform this df num, and it's going to return a numpy array and put that into x. And then after that, we're going to create the data frame from x. So let's call this df num imputed. df num imputed is equal to pd.dataframe. And then DataFrame, we're going to give the x numpy array that we've just created here. And then after that, we're going to give the columns and index. Let's first get the columns. Columns is equal to df num. Our original data frame is df num dot columns. And then the index is going to be equal to df num dot index. Okay, so that is the things that are needed for creating the data frame. And then after that, let's just take a look at df num imputed, and let's take a look at the structure. And then after running this, as you can see that we have all of the columns as before. The only thing we don't have is the last categorical variable, which is not numerical. So we are not using that for this. And then for only the numerical variables, we have the total bedrooms in this case, and then we have the entire 16,512 rows in this data set. So it's successfully imputed as well. So that's the end of today's BitSize machine learning. So let's quickly summarize what we have learned. So we've learned if our data have some missing values, such as our total bedrooms, for example, like this, and then we can either drop the entire feature, the column, that's the first approach. It's going to get rid of the entire column. Our second approach is dropping only the rows where it has NA values. So we can do that, but it's going to affect the others as well. It's going to reduce the total sample numbers. So that's our second approach. In our third approach, we're going to fill the NA with values, which is also called imputation. So we talked about how to do it manually, first computing the median value of that, and then reinserting that median value into the NA cells, and then impute it this way, or using the SimpleImputer method in scikit-learn using a strategy of median, and then imputing it that way. And then remember that in SimpleImputer, we are only imputing the numerical once, but not the categorical like ocean proximity like this. So this is the end of our today's machine learning. In our next video, we're going to further analyze how to deal with categorical variables like this. So stay tuned. If you like this content, please subscribe and check out other similar videos.